Dr. Chavers. Thank you so much for joining us. It's a pleasure to have you here.
All right, thank you for the introduction. And I'm excited to be here with all of you. I enjoyed the previous keynotes that were given, and I think she had just left, but I resonate with the thought that over planning your life can be stifling and challenging, and I like to make it up as we go sometimes, but being at NASA, it's hard to make it up every day. We have to have a plan because there's so many people that need to align with how we're going to get there. You are the future of space. I've enjoyed being here this morning. I've met several of you. I hope to meet more of you throughout the day today and tomorrow and Saturday. You're going to lead the long-term presence on the moon. You're going to lead first human missions to Mars. You guys are. So that's pretty exciting. So let's kick this off with a short video for some context.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible. With science fiction turned reality, with innovation that has spun industries all their own, and with demonstrations of peace for all humankind.
We soar to the skies of our own planet. We maintain presence just outside of gravity, and we touch force all across the solar system and beyond. We're going back to the moon, and this is what we do.
The moon is a treasure of science. It holds opportunities for us to make discoveries about our own planet, about our sun, and our solar system.
The wonderful galaxy creation will inspire new generations of thought and action.
Without fail, every major program and mission NASA has invested has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and generations to come.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs developed around the world. This is not an ambition of one entity or one country. The expression of the moon is a shared.
Working together for climate desire the greater good. Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of our Artemis generation today. Because the management era has already begun.
And because we want to solve, we need to learn what it takes to establish a community on another cosmic shore. So let's get close before pushing out.
And so, we go to the moon now, not as a series of isolated missions. Let's build a community on and around the moon, capable of proving how to live on other worlds.
All right, that's pretty exciting and gets me pumped up when I watch the videos like that. But I'm not going to talk only about Artemis today, but it's going to be a big bulk of the presentation. But I want to give you talk a little bit about the inspiration behind the name Artemis. Artemis was the goddess of the moon and twin sister of Apollo in Greek mythology. Clearly a great complement to the world-changing Apollo program of the 20th century, right? So, but Artemis also represents women, and this is important to me. As a leader in human spaceflight, I feel that it is imperative that we acknowledge and honor women and their contributions to the industry that has and will continue to change the course of humanity. And we just heard some of that in the previous keynote address that we had. Resonate with a lot of what she said. everything she said. It's important to me as a husband and as a father. My wife is an electrical engineer. She started out as a stay-at-home mom. We had 3 children, 2 daughters and a son. And when I was interviewing to be an astronaut, and I wasn't selected, but I did interview to be an astronaut when we had 3 children. And I was being mentored by an astronaut friend at the time, and he told me, well, you know, if something goes bad, that's going to be it for you. But what about who you leave behind? And so he talked with my wife and his wife as well. And so my wife said, I think I can go be an engineer. So when our youngest started kindergarten, she started school as well. So it was challenging. She would help the kids with homework. I'd do supper. After we put the kids to bed, we'd work on her homework for 6 years. So she got her electrical engineering degree, and now she works for a missile defense company. My 2 daughters, 28 and 26 years old now. Marissa's a mechanical engineer. Malia's a civil engineer. My daughter Marissa recently asked if she could talk with a friend of mine, Lisa Watson Morgan, who's program manager for the Human Landing System, about some career advice. I thought, well, surely she'd ask me. Well, but Lisa had a perspective that I didn't. So I found out later she wanted to talk with Lisa because she was a mother of 3, successful leader and engineer at NASA. And she needed to ask her about, could you be a successful mother and have a successful career? So, which was, I thought, exciting after I learned about that. So there's potential of me being a grandfather soon is pretty neat. But I think it's important that for my daughters who have ambitions of being mothers one day and successful leaders in their field, to have role models, engineers and leaders, even astronauts that they can look up to as they were growing up. So Artemis, it represents diversity in other ways too. And the representation of everyone to successfully complete the missions that we have and what we need to do. And it's important to me, it's important to NASA, it's important to me personally. So in the 20th century, we had our 12 white Apollo heroes, and they were heroes to all of us, walked on the lunar surface. In the 21st century, we will ensure that our Artemis heroes are not just women, but also people of color and people of other races, other countries. We're working to be inclusive and take people of other nationalities to the lunar surface. So we have an incredibly diverse astronaut corps, and NASA is committed to that mission equity in all of human spaceflight. Okay, so let's get to it. Let's talk about Artemis as a foundation for deep space exploration. Here we have a snapshot of the ground of Space Launch System, the Orion spacecraft, exploration ground systems, which will ferry the astronauts between the gateway from Earth to the gateway, and that the Space Launch System, Orion, and exploration ground systems are foundational for the transportation from Earth to the gateway. So we're working with U.S. industry on the Human Landing System, and that's to ferry astronauts between the gateway and lunar orbit and the lunar surface. And we also have industry working on spacesuits. And this is one of, when we first came up with this and started talking about it, I thought NASA would always have the spacesuit as an in-house activity. But then we started thinking about how are we going to promote commercialization and privatization? It's not NASA's job, not our intent, to be a government furnished equipment to this. And now we've seen we have private astronaut missions. And so in that effort, we're going to have the suits provided for our NASA astronauts as a service, not as an in-house build, so that we are intentionally preparing for the ability of private citizens to go and work in space. And if we didn't have suits when we got to the moon, the scientists would not be very happy about that, to go all that way and to have someone go out. So NASA and our partners across the globe, we have an incredible space communications network, keeping us connected to our crew and robots in space. And that's growing. For around the moon, we have a plan to build up more capability around the surface so we can communicate in places where we don't have direct communication with Earth. And of course, we talk about Artemis Base Camp, and which we're going to be building up to. And that starts, the very start of that is with surface mobility. And we'll start out with a lunar terrain vehicle built by private sector as well. So I'll step quickly through a few slides. This slide shows several missions. We're starting out with Artemis 1, which will come up very soon in the next few months, followed by Artemis 2 with humans in orbit around the moon, and then Gateway, and then Artemis 3 through 5, with which will include the first landing of humans back on the moon. And then starting on the left-hand side with Artemis 5, and have increasingly complex missions as we lead up to the Artemis Base Camp. So shown here, pictures just from last night, yesterday, with Orion being stacked on SLS. And I was very fortunate to go see SLS a few weeks ago before the cable testing. And it's a very big rocket that's stacked up there, very capable. So on to Artemis Base Camp. And this is just showing the conceptual pieces we have now of Artemis Base Camp. And it'll be more elements than this even. But as we build up to this, this is what we've envisioned as the initial capability for Artemis Base Camp. The human landing system, which will be what carries our first female and first person of color to the lunar surface. Many of you may have followed this in the news. We've been really trying to get going on this the past couple of years. We got a challenge to go really fast from the previous administration, and we have things in place that are going to help us get there. And fortunately, in the new administration, the United States came in, we have what we've been calling continuity of purpose. We didn't change destinations. Artemis is still going, so we're pretty excited about that. The unpressurized rover or lunar terrain vehicle that I just mentioned to carry 2 astronauts so we can have further traverses away from the lander, followed by a pressurized rover, which actually gives us up to 30 days for 2 crew away from the lander and increases the path and traverse path that we can get to for science and exploration. A surface habitat, again, another step in increasing the habitation capability on the surface so that we can have 4 crew members on the surface for up to 60 days. Some of the infrastructure that we're going to need, the fission surface power. There's been goals of finding places of permanent light on the moon so that we could put up solar arrays and have light continuously. And there are places that get close, but even at the South Pole, there are eclipses of up to 100 hours. But if you get away from the pole, you're going to have the 2 weeks of darkness. And so the fission surface power, especially for when humans are there or we're doing any large processing, we're going to need the power that we can get from the fission surface power. In situ resource utilization. As one step to even getting to Mars, we want to capitalize on the resources on the moon, whether it's through propellant production or oxygen for our environmental life control systems. And so and even extracting metals from the regolith for autonomous construction. So there's several purposes for the ISRU that we can do there. And even though the regolith is different on Mars than the moon, the processes and the planning and operations that we would use to extract and store and utilize those materials are very similar. And so Artemis will start with commercial lunar payload services. We have our first missions coming up this next year with Astrobotic and Intuitive Machines, which starts us getting back to the lunar surface again as the beginning of the Artemis campaign. And the campaign is a series of many missions to accomplish the objectives that we have. Gateway. And Gateway is not just a space station around the moon. It's a space vehicle. We can change orbits with the Gateway. We've decided that the first place the Gateway goes is the near rectilinear halo orbit, which has lots of benefits. For one, station keeping is very small impact on delta V for in that orbit. We have continuous comm, and it really makes us a good orbit for Gateway. Some of the early payloads that we've got listed here show that that Gateway has international partnerships that we have. We've got several payloads that are going to be a part of that. The transit habitat. So if we're going to Mars, we're going to need something to live in for the crew to live in while we go there. And so there's a concept here of an inflatable habitat to go from the near rectilinear halo orbit to Mars that provides habitation for the crew. It's intended to have a 15-year lifetime, so we can use it for multiple missions. So the transit to Mars is going to be 2 to 3 years to go there and back. So the Moon to Mars architecture, and we talked about campaigns and architectures at NASA. So all of this is built on many missions. It's not all one mission and we're done. And every mission is built up on the previous missions before that. That's what the campaign is about. We saw a few minutes ago about Mars sample return, which is a buildup of several missions to actually get those samples back. And I'll be meeting with the program manager for Mars sample return to understand what they did in their planning to do that, and what lessons learned we can do as we build up the Artemis campaign and our Moon to Mars architecture when I get back to the US after IAC. So shown here, we've looked at what Mars looks like on the right, what elements we would need there, and we've mapped that back to the Moon because it's a very similar architecture that we need to accomplish our objectives on the Moon. And the attributes that's listed in the middle here are some of those attributes that are common between both Moon and Mars. So operations at the Moon prepares us for Mars. Like I said, the round trip will take at least 2 years. And once the ship's course is set, there's no turning back. There's no abort capability that we have within our transportation systems to go while we're going to the Moon. So as much as possible, we want to use the lunar systems designed for dual purpose and check them out on the Moon, use them a lot, see if we need to make upgrades before we carry those type of elements to Mars. Integrated missions in the lunar vicinity will prepare us for successful Mars missions, and we're calling these analog missions. One example is the human system itself. We don't know how the crew is going to react to being in space for up to a year and then being in microgravity. How soon can they get out of the vehicle for the first EVA? And we've studied what happens when they go from 0G to 1G, and it takes time for them to recover. And we would assume that it would take less time in low gravity, like on the Moon and Mars, but we don't know. We haven't tried that. So, what is success? So in order to accomplish what we want for Artemis and the Moon to Mars, we're going to have a lot of successes along the way. So what is success? So when we do these really big things, like humans living and working in space and on other worlds, we ask ourselves, what does success look like? What did it take to be successful? And so, Artemis and Apollo, we look to the Greeks for those names. So once again, we look to the Greeks. A young man asked Socrates, and you may be aware of this story, what is the secret to success? Socrates asked the young man to walk to him into the river. When the water reached about their chest, Socrates suddenly thrust the young man's head into the water. And not expecting this sudden move, the man struggled to escape Socrates' clutches. But Socrates held him under until the young man's face turned blue. Socrates then pulled the man's head out of the water. The young man gasped and then takes a deep breath. Socrates asked, "What did you want the most when your head was in the water?" The young man replied, "Air." Socrates said, This is the secret to success. When you want success as badly as you want the air while you're in the water, then you'll get it. There's no other secret. So I've been using the word passion to describe the wanting something as badly as the air described in this example. We heard passion in the previous keynotes. You know, what is your passion? Having passion in what we're trying to achieve. And so talking to the you that I have met and looking at what you guys are doing here, I believe there's no question here. You have passion. So we will be successful. And the fact that you are here today shows that you're pursuing your passion for exploration. And it shows me that you're going to be successful. There will be lots of challenges on the way, lots of them. So we should look forward to these challenges, knowing that going through these challenges that we have, a lot of them technical, political, social, cultural challenges. As we work through these challenges, it brings patience, and patience brings experience, and experience brings hope. Because as we accomplish and get each success, then we'll have that long-term success, knowing that when we work together and we're successful on the initial things, that we can be successful long-term together. So there's another saying that resonates with me. If you want to go fast, go alone. If you want to go far, go together. So we've done fast in the 20th century in Apollo. We went as fast as we could. It was a race to get to the moon. And when NASA was challenged to return humans to the moon in 2024, we thought about that. We looked at a team that would go just focus on 2024 and another team that would go focus on the long-term sustainability of the moon, and realized that those activities could diverge so much that the resources invested to get there would not be applicable long-term. And so what we've done is, yes, we're going to go fast. We're also going to understand how we can build upon going fast to meet our long-term sustainability goals. So we're doing both. We're going fast and far, which requires us to plan the overall Artemis campaign flexibility to leverage what we learn on the early missions to inform those later missions. And so that's where, again, resonating with what our first speaker said. We're going to have a plan, but we're going to have a flexible plan so that we can adjust as we learn, take advantage of innovations, de-scope where we weren't able to meet requirements that we set on ourselves. So Artemis is humanity's return to the moon. We'll still go as fast as we can, but it's far more important that we go together. And that's how we're going to do space in the 21st century. Okay, so NASA's SGC Exploration Working Group is what we sponsored, what our team at NASA is sponsoring. And so we're asking here we go. All right, so this is why we're really here. Although this is my first year at SGC, and I thank you for letting me participate in this. And we've been sponsoring the Exploration Working Group since 2015, our organization has. And so why do we do it? What's the benefit to NASA for sponsoring this? Well, put simply, you are the benefit. Tapping into the creative minds that you have is essential. Gaining new international perspectives makes exploration richer. It was at the International Program Management Training class that I learned the proverb that I just mentioned on the previous chart. And this unique opportunity to share working group recommendations with the UN is phenomenal. How to tap into your creativity. So this year we're asking the Exploration Working Group to think critically about these 4 topics on the right. Astronaut science at the moon, opportunities to leverage crowdsourcing and citizen science, opportunities for emerging nations to contribute to Artemis, and how activities on the moon can have a positive impact on life here on Earth. So I also want to highlight Emily Judd. Emily, where are you? There's Emily back there. So we sponsored her scholarship to come here. So say hi to Emily when you get a chance. She's a rock star, supporting our Mars architecture team that reports to me. So please say hi to her when you get a chance. Okay, how am I doing on time? Okay, okay. So just one more thing I'd like to throw in here before closing. One last example culturally, and this is not for you. I don't see any tendencies like this from you guys, but you seem to work very collaboratively and interested in promoting each other, which is wonderful. But I'll just share one more thing with you. So growing up in the U.S., I've heard the term saving face, and that's where you do things to protect your reputation, work overtime to make sure you meet deadlines to protect yourself. Well, I did learn working internationally with some friends in Taiwan last decade, working to develop a robotic lander for landing on the moon, and we were on track there, but through budget and political reasons, we weren't able to finish it. But I learned through them and working closely with them, there's another term called giving face. I hadn't heard that one before. And so when they explained what that was, I thought, well, that's the right thing to do. And it resonated with me. And that is treating others with respect and dignity in a way that promotes others to treat them with respect and dignity. And so even though that's been an attribute or characteristic that I've respected all along, I didn't have that term for it. And so that term of giving face, I think is important as we work together culturally across international boundaries. And every country has those types of attributes if we just look at it. So I wanted to leave that with you because of being able to work with my friends internationally. I've learned a lot more about myself, about our culture, and I think it's just a wonderful thing to do. And I'm pretty excited about what you guys are doing. I wish I'd been a part of SGC earlier, but I think I aged out a long time ago from doing that. So thank you. I'm excited to be here, and I look forward to meeting you and following your careers as you lead us back to the moon and Mars. Thank you.
So much, that was really great. I think we're all excited to what's happening for Artemis and the moon. We have time for a brief refresher, so we'll just wait at front of here and we'll come up to stage.
Thank you. My name is Kevin from British Columbia, Canada, and we like to hear you talk all about the international collaboration efforts that we're part of the Artemis program and integrated 1 month. But at the same time, I can't help but notice students that I work with in my own university have a real struggle to figure out how we can work internationally. We only go through the ITAR requirements. I'm sure people in the room know what I'm talking about. So how do you see those high-level goals for collaboration kind of making it to the lower levels where people are actually working on projects?
But that's a very good question. And we are actively engaging internationally to try to figure out those things. There's several ways to do that. There are contributions at the element level, at the system level. There's contributions at the component levels, which is really where we get into the ITAR activities and also EAR restrictions as well. There are ways to work that. For example, with Canada now, we're looking at CSA has been very interested in providing the robotic arm for that lunar terrain vehicle. So in addition to carrying 2 crew, we want to use that vehicle the other 51 weeks out of the year to do science. But how do we get around those restrictions? That is forward work. We have regulations. And for us, those come through the State Department, Department of State. But there are ways to, I won't say get around it, but meet the intent of the ITAR and still collaborate and work together. So that is our intention. I know Pam Melroy will be here, the Deputy NASA Administrator this week, and she's going to be meeting with all of the heads of agencies, and that is her top list on how do we get more partnerships internationally with Artemis. So we're intending to make sure we can do that.
Can you do anything on that question? All right, it's all better for folks through.
Thanks for the presentation. From a role, I'd like to know what is the role, or at least how space emerging countries or non-space current countries are really contributing to this space exploration roadmaps and programs, or how they can contribute,
Okay. And this is going to be one of the topics of the working group as well, is how the emerging space countries that may not have a lot of space infrastructure, how they can contribute. And this is being a little bit jet lagged. I woke up at 11 p.m. last night, and so one of the things I was thinking about all night, how do we do that? So we're going to be challenging the working group to think about ways these emerging countries can participate, and we haven't talked it with Aaron and Nicole yet, but I want to also flip that around. How do we help them engage, and how do we help them, these emerging countries, not just help Artemis, how does Artemis help these emerging countries? So it may not be the answer you're looking to, and in short, there's several ways to contribute to Artemis, but we want to do it in a way that provides that we can give face to these emerging countries so that they can be respected for their contributions and build upon those contributions for their countries. So it can be anywhere from components, subsystems, data analysis. There's a whole list of things that can be contributed that we have a list for, and we just need to be able to communicate and talk with them to figure out how to get them on board.
All right, guys, time for one more question. I'll do a quick check for any online ones. No,
Thank you, Dr. for the presentation. The beginning of you told us about planning, and we know that Artemis has several ways in the past, maybe 4 points, and how NASA is trying to mitigate these aspects moving forward.
Can you say it again? What aspects of missed them?
You mentioned about planning. We know that Artemis has several ways in the past, even before points, and how NASA is trying to mitigate this aspect of creating this.
Creating architecture? I'm sorry, I didn't.
delays.
Oh, delays. Oh, how to mitigate the delays? That's a good question, and we, going to the moon is hard, and we make plans, and this goes back to we can make a plan, but there is no perfect plan. We run into things leading up to Artemis 1, for example, as we were preparing SLS and Orion. I think we've had 5 hurricanes in Florida this year that we could not have planned for. So there are things that come against us and challenge the plan and make us replan. We just have to do that. Part of our planning involves what we understand about the budget. Okay, and so in our budget process, we make an assumption about a budget we're going to get, and these big programs are multi-year, multi-administration plans with stakeholders involved. And so one of the things that we're doing, we're actively is getting more engaged with all of the stakeholders to understand what the plans are. And so from NASA's perspective, the appropriators, the ones that provide the budget, make sure they have buy-in and understand the implications to the budgeting that we have. So that's one aspect of making sure we can mitigate delays. Others is, with our international partners, and they all have the same challenges with the ministries of finance and so forth, and just communicating and making sure we're aware of the sensitivities of each other's challenges there financially is one way to help mitigate the risk of delays. All right, is that it? I want to thank Aaron Mahoney and Nicole Herman and Nate McIntyre, who's online, I think, as well, for helping with this presentation. So thank you, guys.
All right, thank you so much. Everyone.